Okay, I did the last video explaining this process, the setup, and how to get the different readings. But what I wasn't so clear on was the actual amount of current. Right now, this is on the 20 microamp scale. Okay, let me try to. I'm trying to show you. I can keep my hand steady enough. So this is the 20 microamp scale. Okay, so what the current actually is very small. If this is the 20 microamp scale, what's registering right now as I have the junction, right, of the two metals around this source right here, at this distance from the flame, what's registering on the scale is actually less than a microamp. It's 0.03 microamps. So that's actually well, if how does it go? You got milli, then you have micro, and then you have nano, right? So what you're looking at right now is 40 nanoamps. That's what you're looking at. It's very small, and like I said, I use some of the experiments I'm going to be that I'm looking into requires extremely low current. A lot of the experiments I'm trying to do with biology, in you know, dealing with biology related experiments that require very low voltages. Some of them have to do with stem cell, making stem cells at home. What you do is a process called electrophoresis, where you can drive ions into tissue, into cells, and depending on the amount of voltage and or current, the size of the materials that you're driving in could be controlled. Okay, so if you want to deal with micron size, or the micron size of materials that's going to be drawn in, and one of the things I'm going to be using is silver. I'm going to be using silver. Silver is I'm gonna try it as the anode and the cathode in different situations, and depending on the size of the metal, which in this case, in that case, would be silver, I'll be able to send particles of silver into the tissue, into the cytoplasm, and like I said, if it's small enough, the cells can actually work with it to initiate the different parts of the production of stem cells that has to do with taking differentiated cells, de-differentiating them, and then re-differentiating them into what the surrounding tissue requires, based on how much damaged tissue is around, and a variety of different things like that. So like I said, what I'm trying to use the extremely small voltages and currents for is for these biological experiments. Okay, so I hope that explains some of it. So once again, I don't know if I made clear the voltage, so let me set this thing up for voltage. And just to let you know, the voltage that could be controlled. Okay, let me put it down. Okay, so right now it's at the 200 millivolt range. So right now what you're looking at is 1 point. It's fluctuating, but you know, around 1.6 to, you know, well, look, we're all the way up to 2 millivolt range. Okay, and something is pretty interesting about all of this too, is because you see the negative you have negative 2.8 volts going up 3 volts, you know. I've been reading also about different, as you pay attention to different materials, different elements on the periodic table of elements, I read that in making a power source of cells, either cells or batteries or whatever, the way the negative and the positive is chosen is based on the two materials that you use. So for example, in this situation I'm using aluminum and I'm using copper. On the on the elemental chart, one is actually larger than the other one. Okay? So the relationship of which is larger to the other is what determines which one is going to be positive. So in this case, the aluminum is negative. Okay? The aluminum is negative. Okay. In another situation, the aluminum could actually be the positive. It could actually be the positive atom. So in this one, it's the aluminum is playing as the negative atom. And something very interesting is going on, because this voltage is going sky high right now. I haven't even seen it go this high before. It's up to 8 millivolts, going up to 9 millivolts. This is really interesting. And like I said, it's on the negative side, and normally it was this arrangement showed a positive voltage reading. So what this is indicating to me is something has happened to cause the electrical flow to reverse. Look, we're all the way up to the 10 millivolt range. I'm gonna just keep it, see how high it goes. So if in the original setup where the aluminum is the negative and the copper is the positive, the way I perceive it is that energy, if this is the positive one, it's the one that's sending energy outwards, and this is the negative, that's the one that's absorbing the energy into it. Okay? So as I see it, the flow was going in this direction, from the copper to the aluminum. So what's at one end of the copper? Nothing. And what's at the other end of the aluminum? Nothing. So where exactly is this voltage coming from? And that leads into a whole nother explanation of, you know, of the generation of the really where energy is actually generated from. But as I understand it, you can set up materials in nature to draw energy from wherever energy is really coming from, the very energy that's used to create the material itself. You set up a imbalance situation, and the energy would be drawn in to the material. It will be drawn into a material and then out through another material, through the source. So like I said, that's interesting. And like I said, I haven't seen this do this, so something's going on. I'll just keep it to see how high it goes. You know, it's up to 18 volts. So that's that. I'm gonna stop the video and take a different see how, you know, I'm gonna keep it here, see how far it goes.